Okay, so I wanted to give you a couple more examples of using method number 3 to factor these two trinomials here that I have on the board. Recall that, I don't have it printed right here, but recall that it is essentially important to factor the greatest common factor first when using method number 3. So let's take a look at the first example. And it appears that indeed there is a greatest common factor. I can take out 2. And it's not much, but we need to take it out. And what we're left with there is 6x squared minus x minus 2. And now I'm going to focus on this trinomial left within the brackets. We've actually looked at this before. Let's explore this. We should have the factors known already. But we're going to do method number 3. Multiply a times c to give negative 12. And then I'm going to factor negative 12 into the two numbers that make up negative 12 that also add to negative 1, which is our middle coefficient right here. So I could try 1 times negative 12. No, that's clearly not going to work. If you see what's going to work right away, feel free to go directly to that. For example, I can say, all right, I know that 3 times negative 4 is going to give me negative 12. I also know that that adds to negative 1. So those are the numbers that I'm looking for. Remember, with method number 3, these two things become the numerators of the fractions in our binomials that start with x plus, there's my 3, that's the numerator to the fraction. Always use the leading coefficient for the denominator. So 6 in this case. The other binomial is x minus 4 over 6. That's the beginning element. Reduce those fractions as the next step. So that gives me x plus 1/2 here and x minus 2/3 here. And remember, the last part of this crazy method is to drag these denominators up in front of the x. Those become the coefficients. So now we have 2x plus 1 and 3x minus 2. And at this point, these two binomial factors indeed equal the trinomial 6x squared minus x minus 2. But don't forget about that greatest common factor. So in the end, if I can bring this all the way down, what we have is 2 times 2x plus 1 times 3x minus 2. Okay, there we go. Put a little box around this. And this is our final result. And it looks like we're okay. Hopefully that's on the screen. Let me double check. Yeah, that looks okay. Let's take a look at the 4x squared plus 3x minus 3 using method number 3. Now, we don't have a greatest common factor for this one. That's okay, no big deal. But look for that first, especially with method number 3. Always do it, especially do it with method number 3. Now, I'm going to start with multiplying a times c. 4 times negative 3 is negative 12. Didn't mean to do that, but that's okay. What are the two factors of negative 12 that multiply to give us this, add to give us 1? Well, we're going to go the other way around. We're going to do 4 times negative 3 this time. Those things multiply to give us negative 12. They add to give us positive 1. So again, those become the numerators in these two binomials, x plus 4 over, always the leading coefficient is the denominator for both binomials. Okay, there we go. Look to see if you can reduce, and we can. This gives me x plus 1. The second one I can't reduce, so it's just x minus 3/4. Okay. And finally, bring that denominator up in front of the x. And in fact, at this point, I can say this is equal to the original trinomial. We've got x plus 1 times 4x minus 3. And that is it right there. And at this point, you might be saying, oh, I love method number 3. It might not quite be as reasonable, however, as method number 2 or method number 1. So it's really up to you. Use what you like, use what you know how to do. But this is, in my book, an approved procedure. So let me move on to one more video to show you some additional examples of factoring by grouping.